To integrate sine raised to some power of x times cosine raised to some power of nx dx, we will have three cases. Okay, the case 1, the exponent, the power n is an odd. Okay, power of cosine, which is n, is odd regardless of m. In that case, when n is odd, what we're gonna do, we write, like, let's say we might have like cosine 5x or cosine cube x or 7, 9, 11, etc. We have to save one cosine. Okay, save one cosine. Then the remaining cosine will be an even power. Like if we have 11, then 1 is there, we have 10. And use the formula cosine square equals 1 minus sine square to change the remaining cosine in terms of sine. Okay, like for example, if we have sine, let's say cube, I mean this doesn't matter, we are focusing on cosine, let's say 5x dx. If you want to integrate this, then what you have to do is sine cube is just as it is. Now cosine fifth, save one cosine, that goes for in fact du when we make u substitution later. Cosine 5, so 1 is there, so remaining is cosine 4. And we will change cosine fourth in terms of sine, because cosine fourth is same as cosine square, quantity square, and cosine square is given by here 1 minus sine square. In any case, everything else will be in terms of sine. Then we say u equals sine, and when we take the derivative and write equivalent differential, we get du equals cosine x dx. All that means this will be a function of sine, or in our case u, function of u, and this will be du. Okay, this will be function of u and du, and we know how to integrate that. Case 2, which is equivalent if the power of sine is m is odd. So we are trying to integrate sine m x some power and cosine nx dx. Now we are considering the case 2 where m is an odd number. Then it works in the similar way. What we're gonna do, we save one sine, and we will have now sine raised to even power. Change those sine in terms of cosine. Save one sine and use the formula, save one sine x and use the formula sine square x equals 1 minus cosine square x to change everything in terms of cosine. For example, if we have like say sine 11x and cosine square x, in this case, since the power of sine is an odd, we want to save one sine at the end, sine x dx, and it becomes now sine, how many left, 10 x cosine square x. Now we want to change this sine in terms of cosine using the formula sine square equals 1 minus cosine square. So sine to the 10th is same as sine square to the 5th, sine square to the 5th, and sine square is 1 minus cosine square. Okay, times cosine square x sine x dx, and we make the substitution u be cosine, then the differential is derivative of cosine is negative sine x dx. Negative is missing, but we can always multiply by negative here and negative in the front. In any case, this will be in terms of du, it will be du, and the remaining will be a function of u, so we can integrate easily. Now the last case, if both powers, okay, case 3, if m and n are both even in our like sine mx cosine nx dx, if both exponents are even, then we have to go for half angle formula, which are sine square is 1 minus cosine 2x over 2, and cosine square is 1 plus cosine 2x all over 2. Okay, look at the other examples I have worked out in this section.